time to review for your radicals test here for some cube roots. What we have here, first we're solving. If I have a square root, that means I need to square both sides of the equation. The square and the square root cancel each other out, leaving me 3x plus 4 equals 7 squared, which is 49. And just we solve like normal. So subtract 4 from both sides to get 45. Divide by 3 to get x equals 15. Over here, the cube root, that means now I need to cube both sides. So the cube and the cube root cancel out, leaving you x minus 8 equals 5 cubed is 125. Add 8 to both sides to get x equals 133 as your answer. Down here, we need to first get the radical by itself. We do that by subtracting 8 from both sides. That leaves you the square root of x minus 6 equals negative 4. Here's the trick right here. The square root of something can never be a negative number. This is a no solution. This is a dips problem here. Now, say you forgot that. You would have solved this by squaring both sides. X minus 6 would equal negative 4 squared is positive 16. You'd have gotten x equals 22 as an answer. If you went and checked all your answers, which you always should, especially with a square root problem, plug this in. 22 minus 6 is 16. The square root of that is 4. 4 plus 8 is 12. That would give you that 12 is the same as 4, which it most certainly is not, so that should not work. That's a way you can always check yourself to make sure your answer is correct. Alright, with this one, we have a cube root. We need to get rid of it, but we need to first get things to the other side. So I'll have the cube root of x plus 9. I subtract 5 from both sides to do that will equal negative 3. A cubed root can equal a negative number. So I'm just going to cube both sides to make that happen. The cubed root, or the cube of, for the negative 3 is negative 27. Over here they cancel out to give you x plus 9. From there, just subtract 9 from both sides. X equals negative 36. Over here, now we have rational powers. First, we need to make it so that this x to the whatever power is by itself. Subtract 1 from both sides to do that. X to the 1/6 power. Then I'll divide by 4. It leaves you 2 equals x to the 1/6. I need to raise both sides now to get rid of the 1/6. I'd raise it to the 6 over 1, or just the 6th power. So my answer is x equals 2 to the 6th, and 2 to the 6th power is 64. There's your answer for number 5. Number 6, I already have the rational exponent by itself. So now we'll just raise that to the 2/3 power on both sides. Those will cancel out, leave you with x minus 14. I need to say, what is 27 to the 2/3? Remember, it's always power over root. So do the third root of 27, which is 3, and then do the second power of that. 3 squared is 9. So then just add 14 to both sides. X equals 23 is your answer. Alright, continuing forward, some more rational powers here. Again, need to first get the x to the negative 1/3 by itself. Add 1 to both sides. 5 equals 10x to the negative 1/3. A lot of you want to try to do something with this right now, but it's not by itself yet. Divide both sides by 10 first. 5 divided by 10 is 1/2. That gives you is equal to x to the negative 1/3 power. From there, to get rid of the negative exponent, to make it positive, I need to take the other side and flip it over a fraction. 1/2 becomes 2 over 1. I now have x to the positive 1/3 power. Then from there, I'm just going to cube both sides, and that means x equals 2 cubed, which is 8 as your answer. Alright, for this one over here, first, subtracting 10 from both sides. To subtract 10, that really means I'm subtracting 20 over 2. That way I have a common denominator over here. That leaves you 4x to the negative 3/4 equals, when I subtract that, leaves me 1/2. I need to divide both sides by 4. X to the negative 3/4 will equal 1/2 divided by 4. That's the same as times 1 over 4 when I do that. So I have 1 over 8. Get rid of the negative exponent by flipping the fraction on the other side. X to the 3/4 power now equals 8 over 1. And to get rid of that, I need to then raise both sides here. It would be to the 4 over 3 power. So the cubed root of 8 for the bottom is 2. 2 to the 4th power is 16. And that's your final answer, x equals 16. Alright, 9 through 12 are the biggest issue for extraneous roots. First, get the square root part by itself. In number 9, we need to subtract 5 from both sides to do that. So I have the square root of x plus 1 equals x minus 5. Now square both sides. When I square both sides, that really means this is x minus 5 times x minus 5 equals, now when I square this side here, just x plus 1. So x squared minus 10x plus 25 equals x plus 1. What I need to do is bring everything over to the left-hand side and then see what happens. I'll probably have to factor again. X squared, it'll be minus 11x when I subtract the x over, and plus 24 when I subtract the 1 over equals 0. Let's factor that. Factors of 24 that add up to 11 would be 8 and 3. So that means my final answers here are x equals 8 and x equals 3. Now here's the kicker. We always need to check and look for extraneous roots. When I check these, if I plug 8 back in, I would get 8 equals 5 plus the square root of 8 plus 1. Square root of 8 plus 1 is square root of 9, which is 3. 8 equals 5 plus 3, which it definitely does, so that's a good answer. Now for 3, does 3 equal 5 plus the square root of 3 plus 1? Does 3 equal 5 plus 2? 3 does not equal 5 plus 2. That does not work. So this answer gets crossed out, and we write this as an extraneous solution, is what I should write. For the next one, we already have the radical by itself, so square both sides. X minus 4 squared is going to be x squared minus 8x plus 16, and that will equal 10 minus 3x over here. When I subtract the 10 and add the 3x to bring it over, I'll get x squared minus 5x plus 6 equals 0. That'll factor to x minus 2 and x minus 3 equals 0, so I get x equals positive 2 and positive 3. Again, we need to check our answers here. If I plug in 2, 2 minus 4 equals the square root of 10 minus 3 times 2 is 6. Does 2 equal, that's the square root of 4. Negative 2 equal positive 2? Definitely does not, so 2 does not work. We also need to check 3. 3 minus 4 equals the square root of 10 minus 3 times 1 is 3. I should have been plugging in 3. 3 times 3 is 9. So does negative 1 equal the square root of 1 is positive 1? Those also do not equal, so we have a no solution because these are both extraneous. This final answer actually is going to be a big old dips, no solution for this one. Number 11, same thing, square both sides. I'll have x squared minus 12x plus 36 will equal 7x minus 54. Subtract the 7x to get, it will become negative 19x. And when I add the 54, I should get 100 for that one, equals 0. Now I can factor, it'll be x minus 10 and x minus 9 equals 0, so your answers are 9 and 10. When I check them, I'm going to plug in first 9. When I plug in 9 minus 6 will equal the square root of 7 times 9 minus 54. So that means that 3 equals the square root of 9. 3 equals 3. That's definitely true. So 9 is a good solid answer. For the other one, 10 minus 6 equals the square root of 7 times 10 minus 54. Well, 7 times 10 is 70. Minus 54 is 16. So does 4 equal the square root of 16? Yes, it definitely does. We have 2 good answers. Both answers work just fine. And this last time, definitely the toughest one we have. First of all, with the square root, let's square both sides. That means this exponent, 3 halves times 2, is going to be just cubed. So x plus 1 cubed will now equal 27x cubed. To get rid of this cube, I'll take the cube root of both sides. That means x plus 1 will equal, when I do the cube root, I need to cube root everything. The cube root of 27 is 3. The cube root of x cubed is just x. And now I'm just solving it like I would normally. I get 1 equals 2x, and that means that x will equal 1/2 as my final answer.
Let's do this for see here.
All right. It's time to graph. So when we graph these, same as always, we're going to first say how we're going to shift it. This one's going to shift to the right 4 and up 1, so there's your starting point. For a square root, when I go over 1, I need to go up the square root of 1, which is 1. To go up 2, I would need to go up 4, or to the right 4, I mean, 1, 2, 3, 4. That way, the square root of 4 is 2. I could go over 9 to go up 3 would be my next step. That's all the further I can go. So here I am, my center, or my original point at 4, 1, going out to the right like that. For this one, it's left negative 2 and down to negative 4. There's your starting point. I'm going to normally go over 1 to go up 1. but this 3 in front means multiply it by 3. So here's my next point. I would only go 1, 2, 3, 4 over to go up 2, but I need to go up not 2, not 4, but now 6. And I don't think I went up. Yeah, I went up enough. And then to go over 9, over here, to go up 3. But instead of 3, I need to go 3, 6, 9 up. So here's what your graph should look like. You started at -4, -2. Alright, for this one, all we did was shift to the left to -6. So that's your new origin, -6, 0. And this negative means instead of going over 1 to go up 1, I'm going to go down that much. I'll go over 1, 2, 3, 4. 1, 2, 3, 4 to go down 2. I'll go over 9 to go down 3. Next I can fit, I'll go over 16 to go down 4, just to be as accurate as I can be. And I have something like that. Alright, for 16, not only are we going to be going down again, but we're also going to be a little bit flatter than normal. So, nothing on the inside, so I'm not going left or right, just up or down to 5. There's my origin at 0, 5. I'm going to go normally over 1 to go up 1. The negative means I go down. The half means I only go down half as much. When I went over 4, I would normally go down 2, but only half that much to 1. Over 3, over 9 to go down 3, but only half that much. So we'll go down 1, 2, 3. Nah, not quite that much. We're going to go down 1 1/2. So something like that as your answer. For this one, the negative's on the inside, so I'm going to flip it horizontally now. My starting point is at here at 0, 3. And when I normally went right 1 to go up 1, now it's just backwards. Left 1 to go up 1. Left 4 to go up 2. Left 9 to go up 3. So I should have a reverse flowing radical square root guy here. Remember, the radicals go only in one direction. The square roots only go in one direction. Last one pretty simple. Left 1 and up 2. So there's your origin at 1, 2. Actually, it's -1, 2. Over 1 up 1. Over 4 to go up 2, and over 9 to go up 3. There's your one direction curve, just side step. Now, the cube roots, they go both directions, okay? Not one direction, we're now dealing with good bands that go both directions, okay? I start -4 and down 6, so there's my origin. I would go over 1 to go up 1, because the cube root of 1 is 1. To go up 2, I need to go to the right 2 cubed, which is 8. So over 8 to go up 2. Same in this direction. Down 1, left 1, and down 2 would mean I need to go left 8. So that would put me out here somewhere at -12. So you should have a curly Q looking guy with the origin here. It was at -4, -6. For this one, it was to the right 1 and up 2 to start. So your origin's at 1, 2. Over 1, up 1, and left 1, down 1. And then I need to go over 8 to go up my second, and I need to go over 8 to go down my second. So, again, another little curly Q type guy, like so. Alright, for the next one, all we're doing, we're not shifting up and down, just right 2. So here's your origin, and it's at point 0, at 2, 0. Negative means instead of going over 1, up 1, I'll go down 1 instead. And then over 8 to go down 2. When I go left, now I'll go up 1, and then I would go left 8 to go up 2. So my little curve, both directions, like so. When we go down again, it's going to be reversed for this one as well. Left 6 and down 1 to start from the transformations. And again, instead of over 1, up 1, it's going to be over 1, down 1. And I can't go any more to the left, but I'll go one more to the right. I need to go over 8 to go down my 2. So here's my graph, like that. And the origin here was at -6, -1. Alright, for number 23, not going left or right, just going up or down, and it's down 2. So here's my origin at 0, -2. I would only go over 1, up 1, but now with the 4 in front means when I go over 1, I'm going up 4. And when I go over 8, I need to go up not 2 like I normally do, but twice as much. So 8 up would put me here at +6. Same in this direction. I would go down 1, but now I'm going to go down 4 times that much. So when I went over 1, I should be down here. And when I go over, when I go over 8, I should now go down all the way to 10, because I need to go down twice as much. So I should have a much wider looking graph, and that was very poorly drawn. Let me try that one again. That's why I always use a pencil, just like so. Alright, and the last one, with the 1/2, I'm not going up or down, there's nothing out here, so it's just going to be starting at to the right 4. So here's your new origin at 4, 0. Up 1, when I go over 1, I go up 1, but now it's only a 1/2 because of the 1/2 in front. Same in this direction, only up a 1/2 when I go to the left 1. I normally would go over to 12 to go up 2, but instead that's when I go up 1. I would normally go left 8 to -4 to go down -2, but now only down 1. So this should look almost perfectly flat, actually. Not too much happening. There you go. There's your radicals. Just remember, square roots in one direction, cube roots in both directions, and that's all you'll need to know.